Welcome to this explainer. Okay, so if you're a focused learner looking to truly understand what's happening under the hood of your network hardware, you are in the exact right place today. Our goal is highly specific. We're going to break down the exact mechanics of how a network switch wakes up, learns its environment from a completely blank slate, and achieves full intelligence. We're going to demystify the magic and see exactly how data moves.
Here is our roadmap for today. First, goodbye hubs, hello switches. Second, the empty MAC table. Third, learn, flood, and forward. Fourth, step-by-step network learning. And finally, number 5, full intelligence achieved.
Section 1. Goodbye hubs, hello switches. Moving past the collision domain.
Okay, let's dive into this by contrasting the chaotic world of the hub with the much more elegant design of the switch. On one side, we have the hub. Now, a hub operates at layer 1, the physical layer, which essentially means it has absolute zero intelligence. It doesn't think, it doesn't decide, it just receives a signal and blindly repeats it out of every single port. It's literally like someone shouting through a megaphone in a crowded room. Because all your devices share the same channel, if two of them transmit at the exact same time, their signals crash into each other, causing a massive collision. But contrast that with the layer 2 switch. A switch is an intelligent device that makes deliberate, calculated decisions. It learns device locations so it can forward data privately and efficiently. It's a real game changer compared to the hub.
Section 2. The empty MAC table. Day 1 on the job.
So the key tool that actually enables a switch to do its job is its MAC address table. When you first power the switch on, this table is completely empty. Think of it like a new receptionist on their very first day on the job. They don't know anyone's name, they have no idea which desk anyone sits at. Literally every person who walks into the building is a complete stranger to them. Now, what's really interesting about this slide is just how completely empty that slate is. Look at our network setup here. We've got PC3, PC4, and PC5 connected directly to the switch on ports 1, 2, and 3. We also have a hub connected over on port 4 with PC1 and PC2 sitting behind it. But look down at the switch MAC table. Totally empty. The status for every single port is just listed as unknown. The switch has absolutely zero knowledge of who is plugged into which port. It has zero intelligence at this very second.
Section 3. Learn, flood, and forward. The 3 rules of switching.
You know, framing the switch's entire existence around just these 3 choices makes complex network traffic completely predictable. It's the rule of 3. First up, learn. The switch reads the source MAC address of an incoming frame and simply records it in the MAC table against the port it arrived on. Second, flood. Whenever the destination MAC is unknown to the switch, it copies the frame and blasts it out of every single port except the one it came from. And third, forward. When the destination MAC is known, it sends the frame only to that one specific port. Learn, flood, forward. That is the whole shebang.
Section 4. Step-by-step network learning. Watching the switch wake up.
All right, let's look at step 2 in our chronological journey. Let's say PC3 wants to talk to PC4. It sends a network frame saying, "Hey, I am Mac PC3 and I want to reach Mac PC4." This frame arrives at the switch on port 1. Before the switch even worries about where it's going to send this frame, it performs its very first learn action. It reads the source MAC, Mac PC3, and logs it into its table. Notice that highlighted row. Port 1 now has Mac PC3 marked as just learned.
But now the switch runs into a bit of a problem. It needs to deliver this frame to Mac PC4. It checks its table, and Mac PC4 is nowhere to be found. Because the switch doesn't know where PC4 lives yet, it has to execute its second rule, flood. The switch copies the frame and sends it out of every single port except port 1. So PC4, PC5, and the hub all get a copy of this frame. PC5 and the hub are going to read the destination MAC, realize, oh, this isn't for us, and just silently discard it.
So the crucial point is, you might be thinking this chaotic flooding is just as bad as a hub, but it's not. This is only a temporary, brief discovery phase. It is not a permanent flaw. The switch is just trying to find out where PC4 lives.
Which brings us right to step 4. PC4 sees that flooded frame, accepts it because it's addressed to it, and sends a reply back down the cable saying, "Hey, I'm Mac PC4, replying to Mac PC3. This reply hits the switch on port 2. Instantly, the switch triggers another learn action. It reads the source MAC of that reply and writes it down. Look at the MAC table now. It has literally doubled in size.
Port 2 is officially mapped to Mac PC4.
And this brilliantly illustrates the true power of the switch. It now needs to deliver PC4's reply back over to PC3. It checks its table, finds Mac PC3 living on port 1, and instead of flooding this time, it executes a direct forward. The frame goes straight to port 1. PC5 and the hub never even see this reply. This is exactly what makes a switch so vastly superior: targeted, private delivery.
Now, we do have a really interesting little caveat on step 6 regarding our old friend, the hub. PC1, sitting behind the hub, sends a frame. The dumb hub blasts it out everywhere, including up the port 4 uplink to our switch. The switch receives it and naturally learns, okay, Mac PC1 is on port 4. But here's the limitation. The switch cannot see inside the Layer 1 hub, so to the switch, both PC1 and PC2 will simply appear to live behind port 4. It can't distinguish them at the port level because it only sees the single cable coming from the hub.
Section 5. Full intelligence achieved. Maximum network efficiency. Let's move to and see how this builds up to step 7. After just a few seconds of normal network activity, the switch has seen frames from every device. That MAC table at the bottom? Fully populated. PC3, PC4, PC5, and the hub devices are all logged. From this point onward, flooding is basically history. Every single frame between known devices is forwarded directly to the correct port. The switch is running at absolute peak performance. So to wrap up this brilliant process, here are your key takeaways. First off, this entire complex learning process happens completely automatically. Zero configuration required by you. You literally just plug it in. Second, once it's learned the layout, the network runs at maximum efficiency with private, targeted delivery. Third, remember that hub caveat: multiple devices behind a hub are going to map to the same single uplink port on your switch. And finally, keep this in the back of your mind. MAC entries are not permanent. They actually expire and get removed after roughly 300 seconds of inactivity. It's called the aging timer.
Which leaves us with a fascinating final thought. Your network learns completely on its own, constantly adjusting on the fly. But what happens to a constantly shifting, sleeping network when devices go silent for that 300 seconds? Well, their entries disappear, and the switch simply goes back to its trusted rule. It will flood again the next time it needs to find them. It's this continuous, incredibly elegant cycle of learning. Thank you so much for joining me for this explainer. I really hope this helped demystify exactly what happens inside your hardware.